All right, so today here's basically what we went over. We had everybody check their grades. They should be updated, so please let me know if anything's missing there. Then we did something called a click battle, which is fairly straightforward. It's in Desmos. Please actually work through that. That will be great. And then we're going to do fraction clothesline, which I will explain in a second, unit conversions, and some useful formulas that are all in a second Desmos. So let's look at kind of what it is that you can expect in that second Desmos. I noticed a problem with some of your ACT work. So this is what I call a fraction clothesline. What we're going to do is we're going to figure out where should 1/2 go. Hopefully you know it's not over here. It is less than 1 and it is more than 0, so it's going to be somewhere in here. But if I left it over there, we'd all be a little upset because it shouldn't be closer to 0 or closer to 1. It should be right in the middle somewhere. So what about these other values? What about 11/5? Well, 11/5, what do I know about this? I know that 5/5 is equal to 1 and 10/5 is equal to 2. And this is definitely bigger than 10/5, but 3 is the same as what? 15/5? So it's going to be somewhere in between 10/5 and 15/5, and this is 2 and this is 3, so it's going to be somewhere between 2 and 3. And is it going to be closer to 2 or to 3? Well, it'll be a little bit closer to 2 because 11/5 is just a little bit bigger than 10/5. The other way that you could very reasonably solve this is literally saying 11 divided by 5, and you would get that that is equal to 2.2, which is, of course, where this is supposed to go. 9/8 is a little bit bigger than 1, right? 8/8 would be 1. So hopefully you would put this one somewhere around there. Okay, getting a little bit more complicated now, but use your estimation skills. It will really help. So this first one right here, we have 1/2 plus 1/3. Well, what do I know about that? I know 1/2 would be right there, and I'm going to add 1/3 to that. Does that put me over 1 or does it put me less than 1? Well, I know that 1/2 is equal to about 0.5, and 1/3 is less than 1/2 because you've thought about a picture of each of these. Here's a third, here's a half. I just have less of the circle filled in on 1/3. So I'm going to start at 1/2 and then I'm going to add less than 1/2. That means that I'm going to end up somewhere around about here because I'm not, if I was adding a half and a half, I'd be at 1. 3 groups of 3/4. Well, let's think about what that might actually look like here. 3/4 would be like that. And if we were going to have 3 sections of those, so that's 2 and that's 3. Well, this is definitely more than 1, right? And in fact, what I could think about is I could think about, and that's not a great color for that, let's say we stole this 4th and filled it in here, and we stole this 4th and filled it in here, then I would have 2 that are whole and a little bit more. So really 3 groups of 3/4 is going to end up somewhere a little bit bigger than 2. And let's move this over here. Sorry about that. Okay. And then 2 minus 8/9. This is 2 minus, and 8/9 is not quite 1. 9/9 would be 1, so it's 2 minus a little bit less than 1. So if I had 2 minus 1, I'd be all the way at 1. But going a little bit less, I'd probably somewhere around about there. Sorry about the overlap here. Okay, so you're going to have some in Desmos that are very like this, and I want you to really practice those estimation skills. Also in Desmos, you're going to come across these 4 formulas, and they are rather important. They just come up a lot, and if you are taking the ACT, you will run into them. Over here we have Pythagoras, and we use Pythagoras for when we are finding the side lengths of a right triangle. If you have A and B, you can get to C. If you have A and C, you can get to B, etc. This right here is what we call the quadratic formula. And this is used for when we have a parabola and I want to know what are those values. Can I get those x values? And that is what you're going to solve for when you actually plug all of these things in. And you would need a formula that looks like ax squared plus bx plus c is equal to y. And then you'd have, of course, your a, b, and c values that you could plug in here. This one down here, this is the midpoint formula. And this is used for if you had, say, -2, 1, that point right there, -2, 1, and the point, let's say, 3, 2. This would be your x1 would be -2, your x2 would be 3, and you'd find the average of those. So -2 plus 3 is 1, divided by 2 is 1/2, which makes sense. You'd need to be about 1/2 there. And then 1 and 2 is 3, and if you divide it by 2, those are your y1 and y2 values, and that would get you your midpoint, which would be right about there. And then this last one, this is ye old classic friend. This is slope, and this is the rise over the run, the change in the y values divided by the change in the x values. The last thing that you worked on today is how to convert between seconds and other things. And really, this is just practicing unit conversion. So one way to think about this is how long is 1,000 seconds? You could just count to 1,000. Or you could say, okay, in 1,000 seconds, I wonder how many minutes that is. Well, I know that in 1 minute, there are 60 seconds. And if you complete this multiplication, what you're going to find is that the seconds will simplify, and you are just left with 1,000 divided by 60, and your label is really going to be minutes. And if you do this multiplication or this division here, you're going to get that this is about 16.7 minutes. So 1,000 seconds is about 17 minutes, a little bit less. How about 1,000,000 seconds? Well, you've got a couple of possibilities here, but one of them is to just create a much longer version of this. So if we were going to do that, I might say 1,000,000 seconds times 1 minute per 60 seconds times, and this is, I could have certainly written 60 minutes per 1 hour here, but the reason that I put minutes in the denominator on the bottom is because I really do want it to be the case that like they're going to simplify where I have minutes and minutes simplifying. So just be aware of that. And then we've got 1 day is 24 hours. Okay, cool. And so my seconds are going to simplify, my hours are going to simplify, and I know from experience at this point that this is going to end up being about 11.6 days. If you do 1,000,000 divided by 60, divided by 60, divided by 24, you get about 11.6 days. Okay, and now you could certainly make an even longer one for 1,000,000,000 seconds here, longer of this, but I also could know that 1,000,000, which is 1 with 6 zeros, multiplied by 1,000 is equal to 1,000,000,000, which is 1 with 9 zeros. And so really what I'm going to get is 1,011.6 days. So if you did that where you said 1,000 times 11.6 days, you should eventually be able to get yourself to the fact that this is 31.7 years. 1,000,000,000 is way longer than 1,000,000. Please do let me know if and where you're getting stuck on this. I hope this is helpful.